All right, thanks everybody for joining us. We're going to be doing a presentation and an overview of the AIA Plus 2030 program. This is a program that AIA Idaho is going to be putting on this fall, starting in August. And we've got Joel Loveland here today with us, one of the key developers of the series, along with AIA Seattle and Better Bricks. Thanks to Better Bricks for helping fund this presentation. We'll be checking the emails, so if anybody has any comments or questions, just go ahead and send those to idl at uidaho.edu, and it's on the video link below your screen there. But otherwise, I'll just go ahead and let Joel get started with the overview and check those emails.
Okay. Thank you, Gunnar. Welcome to the University of Washington Integrated Design Lab in Seattle. We're part of the College of Built Environments. That's the B school for all of you who don't already know. Yeah, the B, see? We're trying to steal that idea from the business school. So, they've always been the B school. What Gunnar mentioned is the AI 2030 workshop series, which I'm here to talk about today. It's sort of an introduction of each one of the workshops, 10 of them in all. And this was developed by Seattle AIA and the 2030, in a partnership with Architecture 2030. We've produced a whole number of the series, meaning the Integrated Design Lab, and I was the moderator for the 2009-2010 series, and our lab really presented about half of the workshop content over those 2 years. So produced by the B School, University of Washington, developed by AIA Seattle and owned by AIA Seattle, and in partnership with Architecture 2030 and Better Bricks. And I know all of you are wondering what Better Bricks is. Well, it's a commercial initiative of the Northwest Energy Efficiency Alliance, which the Alliance is really a nonprofit funded by the electric utilities from the Pacific Northwest, Idaho Power, our regional utilities in the Puget Sound, Seattle City Light, Puget Sound Energy, Tacoma Power, and Snohomish PUD, and many, many others. Better Bricks asked me to show you this slide because they have a great website with lots of information about building performance. So I'd urge you all to go to betterbricks.com. It's a great source of information for high performance buildings. So what is the 2030 workshop series? Well, it was intended by people from Seattle to begin to build a community around high performance buildings, especially high performance energy performance buildings. So we would build a community around that and develop a series where we could sort of begin to teach one another about how to meet this challenge of Architecture 2030. The community is really represented by these buildings that you see on the left, all done by local architects in Seattle, all passing the 2030 challenge when they were built, done by great teams of architects and engineers, either from Seattle, Portland, or both. The workshop series, as I mentioned, is 10 steps, starting with achieving the 2030 challenge. What is the 2030 challenge? Really, secondly, getting to setting targets for the 2030 challenge, energy targets. Then beginning to look at how to do climate analysis using those targets. The importance of conservation and building skins, really developing highly technically proficient and energy efficient building skins. Next, passive systems. Really, we're talking about thermally passive systems, daylighting, integrated lighting, right-sized mechanical equipment, renewable energy on site, and then handing off that project to the owner so that the systems are in place that you can actually operate the building with a reasonable expectation that it's going to perform as designed. Lastly, there's a session with all the architects who are sort of adopting 2030, getting together and discussing what it means to be a 2030 AIA committed firm. So one of the places I like to start is what do we use for text for this? And I think it's always good to have a reference point after you come to a lecture, a workshop for 3 or 4 hours. if I didn't quite get something, where do I go? And there is a great little piece of work that was done by the Committee on the Environment, AIA National, called Achieving the 50 Steps to 50% More Energy Efficient, obviously done prior to 2010. Now the cross out for we have to be 60% more energy efficient. That's a great little text and it's a free download. The links are a little out of date, but it really is structured around achieving this information. And you can see the 50 steps on the right-hand side here. You'll see actually a readable version if you download the text. The way that these workshops are generally structured is there's about a 30-minute review in the beginning, sort of looking back over the previous session. Ideally, there's been a little piece of homework that everyone has done over the intervening month, and getting some information from the group about what they learned from that homework, and then generally a lecture, the real core content of the particular workshop for about 90 minutes, a break. Then there's typically an exercise to get sort of people up and moving and active, another little break, and then a case study, and then end. Essentially running from 8:30 to 12:30, the way we taught it for the first 2 years, 2009, 2010, and going on today, in many cities across the United States, including Seattle and Portland. So workshop 1, the 2030 challenge, setting energy goals with integrated design. I usually would start out identifying the sort of anywhere from 4 to 10 key strategies from the 50 to 50, which I think are good reference points. By the end of the series, we'd have a printed version of the 50 to 50 everyone would have in their hand, and it'd all be tabbed with sort of key strategies for each particular workshop. So when we're talking about integrated design, we're really talking about building form, building orientation, energy modeling, source versus site energy, integrated project delivery as an AIA concept versus integrated design. We're going to talk about space zoning and commissioning at the very beginning. So generally, I've presented this over the first 2 years, 2009, 2010. And the key content, the way that I see that is, what is the problem? And we really come from a culture that over the last 50 years or so in buildings, we've really looked for the silver bullet in how to solve problems. You know, that thing that's going to be, isn't going to cause us a great deal of pain, that's going to solve all of our problems. You know, and commonly it's thought of as maybe a small nuclear power plant somewhere, a tiny little fuel cell that'll be in the basement. Well, I think the really exciting part of this is it's really the architecture. That's the message to the architects and engineers designing the building, is it's the architecture as the solution. And if we're going to find a solution, we have to tunnel through that infamous cost barrier. This is a diagram of that idea. On the horizontal axis here, we see we see operational savings from 10 to 60%. You can think of that as efficiency improvements. And we see on this horizontal line the capital cost, the base capital cost of a particular project. And in order to get an increased efficiency, typically we've always had to pay more money. And our utilities in Puget Sound and many across the Pacific Northwest provide incentives for those energy efficiency improvements. So typically what we've seen is this is a base building, couldn't be any worse than that, passes the energy code. We get an improvement of 10 or 20%, and that extra cost is commonly greatly paid for by the owner, by the utility with a small owner contribution. And to get higher and higher levels of efficiency, we've had to pay greater and greater amounts of money per element of efficiency, per percent of efficiency. What we found in the early 21st century, 2000, 2001, is that we found we were working with architects that were building really efficient schools with great daylighting, and they were building them for exactly the capital costs that the state had outlined. And it made us start to suspect that you could build a much higher performing building if you just had great engineers, great architects working together, and their goal was it just has to perform a lot better. And what we've found in the work that we've done over the last 5 years in first LEED buildings and now living buildings is that once you get to that sort of 50% goal of efficiency, that actual systems start coming out of the building, components come out of the building, and you can save that cash and invest it in the performance things that you want to include in the building. So we're actually seeing buildings that are no additional capital cost at 50 and 60% more energy efficient. That's integrated design. This is a great building that is doing exactly that. This is the Terry Thomas building by Weber Thompson and Stantec Engineering in Seattle. This is the first non-refrigerated, non-air-conditioned office building built in Seattle since about 1955. It's 4 stories. 3 stories on the upper portion of the building are office. First floor is mainly retail. They worked on this building very hard to make it the very best daylit building and very best naturally ventilated building in Seattle with no cooling. If you talk to Tom Marseille, who at the time was at Stantec, the engineer, he would say that they really didn't have their eye on energy efficiency. They just wanted to improve the quality. And we know that generally a baseline building in our region, office building like this, would generally consume a certain number of BTUs per square foot annually, referred to as an energy use index. That's the number you see in the upper left, 107 kBTU per square foot year, its energy use index, for a standard building of this type in Seattle. When they built, this is a LEED Platinum building, I believe, and they built an energy model for this, and the code baseline for this building was 62 kBTUs per square foot year as an energy use index. As designed, as simulated, this building had a 40 EUI energy use index. And if you look at those numbers from 107 to 40, that's more than a 60% improvement. That is the 2030 challenge. And I'll explain it more in detail in a second. So setting targets, the second session. Really alternative energy, energy modeling, integrated project delivery, total building commissioning. Typically, Tom Marseille, who I just mentioned, worked on the Terry Avenue building, Terry Thomas building, and Jared Siliker from Siliker Associates presented this material, and some of this material is taken from them. What is the 2030 challenge? Well, the 2030 challenge is a 60% increase in energy efficiency on buildings that are occupied, new construction that are occupied between 2010 and 2015. The 2030 challenge started in roughly 2008, and it was a 50% increase in energy efficiency over a baseline up to 2010. After 2010, it became a 60% increase. After 2014, meaning 15 to 2020, it's a 70% increase. You can see incrementing to net zero energy by 2030 or 2030. We have to find a baseline, a reference for that energy efficiency improvement, and the system is intended to use Target Finder, which is an Environmental Protection Agency piece of software that's accessible over the website, that if you just Google Target Finder, it'll come up quite quickly, and you'll put in a building of your type in a particular location. You'll put in a little bit more data, and it will generate a baseline common building EUI for your building or your project. And that's based on these climate zones. These are the EPA's climate regions within the United States. In Seattle, we're in climate zone 3, and here in Boise, you are in climate zone 2. You put that data, project data, location data, into Target Finder, and it's going to show you what a median building of your type and in your location consumes in terms of site energy. That's energy delivered through the meter and to your building. So what I thought I would do is, one, tell you a little bit about what that baseline information is and where it comes from, and then two, take you through just really quickly a little exercise that commonly we do at the first week of schematic design with architects. So that baseline comes from something called the Commercial Building Energy Consumption Survey, which is over 5,000 buildings of real data on real buildings, but annualized data. And the National Renewable Energy Lab in Golden, Colorado then built energy models for every one of those 5,000 plus buildings. And from those energy models, they could what we call disaggregate the loads within that overall annual energy use. So they could say so much for lighting, so much for cooling, so much for heating. So the overall number that's in CBEX is real, but the disaggregation is modeled. Now that's a large database. It sits at the US Department of Energy, and you can download that database, and the mother load file for that is file 17. File 17 has over 5,000 rows and about 50 columns of data on these buildings, including when the building was built, how many floors it is, how many square feet it is, what these energy use characteristics are, and a building ID. It's an anonymous building, so we don't know exactly what the building is. So what it does, what Target Finder does then, is it looks, let's say, for an elementary school in your climate region, and it pulls out the median performing school within your climate region. And it tells you that's what you have to be better than. You have to be 50 or now 60% better than that median school. Here, that EUI site energy use is 54. Now, if you dig into CBEX, you'll start to see here 244 individual schools in Climate Zone 3. And you can see the disaggregated energy use for each one of those schools in Climate Zone 3. And then I've taken the median, which has an EUI of 57, and shown you what its energy use, disaggregated energy use is based on the NREL energy model. So this is what we used to refer to as the poor architect's energy model. You know, we were always argued for the last, probably 15 years that we needed to build an energy model early to be able to see what the energy problem was. Well, now we have it. So if you're building a school and it's in Climate Zone 3, you know that if you really want to reduce energy by 60%, you don't want to pick on hot water. You know, what do you want to pick on? You want to pick on heating, lighting, cooling, and ventilation, and dominantly heating. So from that information, we can start at the very earliest stages with the team working towards common goals. We commonly plot something like this the first week of schematic design for the team. On the horizontal axis, you see EUIs, KBTUs per square foot year. And we plot first the target finder median, which in this instance was 54. We look around for school databases in this case in our region to see if other people know how schools perform. And so if we're doing a project in Oregon, turns out the Oregon Department of Energy holds a database of the EUIs for all the schools in Western Oregon. Or we have contacts with school districts that track all their energy data. So what we found is, for this particular case, the common EUI in this school district for a building built recently was about 47. So you can see, if we're going to build it to code probably, we're going to be immediately 7 points below 54 at 47. So we already have some savings built in. If we're looking at 50% reduction when this project was done, we'd be looking at trying to hit 29. A 60% reduction, we'd be trying to hit 23. Now, what does that mean? I mean, that's usually this discussion that happens early. That's the question that's on everybody's mind in this session. And I can tell you that the most energy efficient school that I have seen in the state of Washington being constructed right now has an EUI of 27. So these are hard things to do. Workshop 3, understanding climate. Sort of what are the resources that we have to work with or work against? Series of strategies from 50 to 50. In the last 2 years, we used Chris Flint Chatto from ZGF Architects, who is now the moderator for the session in Portland, the 2030 series in Portland, and teaches this class at the University of Washington for us in the autumn. Chris puts beautiful graphics together and does beautiful analysis to sort of show the architecture students and the architects and engineers in the class exactly what climate means to a particular building. Here, what he's done is he's taken these 5 climate zones and run an energy model or run Target Finder and found out how the performance varies from on the median office building in each one of these climate regions. And the question he'll ask is why? Why does it vary that much when it's the same building? And that's where it starts in terms of understanding climate. So he'll begin to instruct people, and one of the homework assignments is to go out and get a typical meteorological year weather file from the web and plot that data using a simple Excel spreadsheet that he gives to everyone that plots the data, as you can see here, on this XY axis. On the horizontal axis, we have months of the year. On the vertical axis, we have temperatures. So in this plot, the blue lines in the typical meteorological year are the coldest temperatures ever recorded for this location in history. Probably about 75 years of history. The red line are the hottest temperatures ever recorded, and these dots in between are the 8,760 hours in the typical meteorological year tape that the weather file has in it. That weather file is used for the energy simulation. The X's are nighttime temperatures, and the colored dots are daytime temperatures. The bluer the dot, the drier the temperature. The redder the dot, the more humid the temperature. Starts to tell us a little bit something about comfort. And it's something that the people in the class leave with so they can go home, plot this information, and use it in their practice. Building skins, the importance of thermal performance, or basically conservation. Really, it starts with conservation. Paul Schwer of PAE Engineers from Portland and Mike Stefan from Walsh Construction in Seattle give a great talk related to this. They're like our fantastic resources in Puget Sound and Western Oregon. It's a very complex set of issues. One of the, I thought, most interesting charts that Paul showed was the idea of when you think of the amount of glazing and you think of the operating costs of a building, where is that sweet spot where you're increasing glazing to improve daylight, and then all of a sudden, as you increase it more, you start to decrease the thermal performance. And you can see that in this chart, which was developed for the Bullitt Foundation building, at about 40%. So you know it's not a perfect point, but somewhere between 30 and 40-ish% is that sweet spot. You just don't want to go much beyond that in terms of glazing. Both of them talk about critical barriers in the building envelope. And there's an exercise about identifying where to find the place to put an air barrier. Because air tightness is probably one of the most key parts of an energy efficient building and one of the weakest parts of typical commercial building construction. So thermal barriers in terms of how much insulation, not just looking at it in terms of energy performance, but also looking at radiant temperature in the room. So that typically we've looked at decisions on the amount of insulation or the glazing in a window in terms of strictly its energy performance. But if we start to look at thermal comfort, we might be able to actually decrease the interior temperature if the surfaces around us are more comfortable. So they have a long discussion about that, as well as air barriers. They talk about tunneling through the cross barrier, and in the building envelope, where are those components that are really key? And Paul would say the window and the air tightness are the two key components of that. A really good, solid window. But we're now seeing double glazed windows that approach R5. And we're certainly seeing air tightness if it's pressure tested in a commercial building, which is required by the state energy code in the state of Washington now, of very low air changes, which this has. Passive strategies for load reduction are the next sort of middle point of the workshop series. I've given this session, Rob Pena's given this session from our lab, along with Peter Alsbach from Arup Engineering. Again, sort of building that local community of scholarship related to passive systems. What we're looking at are various systems for heating, cooling, and ventilating. One of the first things we really need to start to understand is the difference between ventilation for cooling and ventilation for breathing or fresh air, and how we can start to decouple these systems that traditionally are one. We're ventilating buildings for fresh air mechanically with the same systems that we're heating and cooling them with. And a key strategy is going to be to decouple, to really understand them differently. We can quite easily ventilate most buildings for fresh air through natural systems during the times of year when the temperature outside is a temperature that you would appreciate inside. So what this session will do is it will give you rules of thumb that will start to allow you to size these aperture areas for ventilation for fresh air. And they'll show you examples of this. This happens to be a Miller Hall building in Northeast Seattle. They'll talk about the depth of penetration of that natural ventilation. For instance, sort of a general rule of thumb is if you have window apertures on the perimeter, you can naturally ventilate about 2 times as deep as that window ventilation aperture is high or off the floor. So again, showing examples for natural ventilation and giving you those rules of thumb that really make you dangerous. Daylighting, session number 6. Commonly given by Chris Meek from our lab and Tom Marseille, who you recognize was at Stantec and now is at Flack & Kurtz in Seattle. WSP Flack & Kurtz as the managing partner. The idea is to begin to understand the rhythm of light within a space, to illuminate passively, that define daylight and define criteria that are most usable. The fact that direct sunlight is not daylighting in most instances. That in critical visual task areas, sunlight really has to be kept out or diffused within critical task areas because it's too high, too hot, too bright, creates glare and a lot of thermal stress. So one of the things we start to do is to start to talk about programming for daylighting, identifying the areas that are most critical, that have the critical needs for daylight, and zone those to the perimeter or the top floor in a building, and areas that need less daylight, like circulation areas, to the core. And to have rhythms of daylight within the circulation area. This is a Strawberry Vale School by the Packcow architects. In this corridor, you can see it appears fairly dark. It's not as dark as it appears here. And then the entrance to the classroom is beautifully daylit, which then pulls you into the classroom. There's a rhythm of light and dark within these schools, programmed for daylight zones. Workshop 7 is really right-sized mechanical systems. This is a huge one. It's a pretty long list, as you see. Practically everything in the 50 to 50 is in this list. This is much too much to cover for Peter Alsbach and Brendan Miletus. Alsbach from Arup Engineering. We like to think of this as right sizing. And it goes back to all the sort of fundamental principles of what the whole series is trying to speak to. It talks about architectural systems in terms of conservation and passive systems. It says that you need to have a high performance envelope that balances heat loss issues to radiant comfort issues. It has to really look at solar control. And remember, this is Seattle, not Boise or not Idaho. And that solar control issues are huge in Seattle because if we can minimize solar penetration during the summer, we can actually eliminate cooling in most commercial buildings. So how to minimize that with architectural strategies, and then daylighting to minimize lighting power and the heat from that power. Then building systems, we're really talking about building mechanical systems here. 2 key ideas are really decentralize and decouple your systems. So that old habit we've gotten into of a big package unit on the roof or a big packaged unit in the basement with large ducts and central fans is something we're all trying to get away from. We find that as much as 20% of the cooling load in any particular building is actually the fan heat pushing that air through the building. So what we're starting to look at is dedicated outside air systems, which bring in the minimum amount of air needed for fresh air and do a little bit of baseline thermal tempering, either cooling or heating, and then do an immense amount of heat recovery or coolth recovery on that dedicated outside air system, which ends up being much, much smaller in terms of duct size and space size within the building. For instance, in hospital work that we're doing, we found that we can take up to 2 feet out of the patient tower, 2 feet per floor out of a patient tower, just because the return air duct size has been reduced so much with dedicated outside air systems. So we're decentralizing and decoupling and taking the primary or peak heating and cooling away from the air systems and associating it to liquid systems, 4-pipe systems. We're talking about zonal level sensible cooling with flat plate or cooling systems, chilled beams, radiant panels, fan coil systems like we have in this room. And also zonal level heating systems, radiators, flat panel radiators. Last item here is just doing as much heat recovery as possible. It's absolutely key for building mechanical systems as a concept. And then we like to talk about central plant systems, because in big buildings, there will commonly be large to medium-sized central plant systems. And we're commonly talking about heat pumping systems now that can use various entities as batteries for storing coolth. Not a very good one, but an efficient system at a fairly small scale are air-type heat pumps. We see them in schools all over Puget Sound now, air source heat pumps. We're also seeing ground source heat pumps where we can use the ground as a battery. And the heat pumps are actually modular. So the heat pumping system can be both heating and cooling at the same time in different components of that central plant system. Just a diagram of how these things work. And remember, these are mechanical engineers talking to architects commonly who may or may not have a very good idea of sort of baseline systems in a building. This is sort of the baseline most efficient system that we would look at, which is what we call heat recovery chillers. In a big building, there's heating and cooling commonly going on simultaneously. If you look at this diagram, a big building, this is a hospital, there's a cooling side and a heating side. Instead of having a chiller and a boiler that's doing all the chilling or all the heating, now we have a chiller that we're recovering the heat of and bringing that heat back into the building for reheat or heating in certain areas that don't need cooling. If there's too much cooling, then that heat is rejected to, say, a cooling tower, or if there's more heat needed, then there'll be a small supplemental condensing boiler. And all those terms are oftentimes pretty new to the architects in the room. And then there's a description about a central plant system that's a heat pump system. Ground source heat pump, this being heat being extracted from the building, heat being added to the building. Certain parts of this heat pump are cooling, certain parts of it are heating, and if heat needs to be rejected, it's being rejected into the ground. If heat is needed, then that heat is pulled out of the ground, run through the heat pump, and then brought back into the building. The ground is basically a large battery. Workshop 8, renewable energy opportunities. This is the sort of last gasp, the last thing you want to add to a building to make it more energy efficient, because it's generally the most expensive. Paul Schwer, John Brashears from ZGF. Paul described these graphics which were developed for the Bullitt Foundation building, which is a net zero energy, net zero water living building. It's about to start construction in July. And where he started with that building was to identify what the average target finder building would be of this type, of this size. This is a 5-story office building, and in Target Finder it would have an EUI of about 72. That's the median building performance in this region of an office building. The energy code building for this building would be about 64. A LEED Platinum building, all the LEED credits for energy, would have an EUI of 32. And you can see where this is going. Then you jump to the roof and you say, if I covered the entire roof and the south side of this building with PV, actually I think this was just the roof, if I covered the entire roof, maybe extending out 20 feet over the sidewalk, I could generate an EUI of 16 on an annual basis. So we know that the best buildings in Seattle are running at 32. We know that we can't be more than 16 because that's all the energy we can generate. So what do you do? What do you do? The first proposal for the building had an EUI of 22. And that drove a large panel of PV that covered the south surface of the building. And over the last 6 months, Miller Hull and PAE engineers, Miller Hull architects, have driven that proposed building EUI down to the latest number I think I saw was 13. And they pulled the PV off the south side of the building. They're back to a PV budget of 16. And it looks like it's a go. So that's an interesting story that Paul will tell about a real project, meeting the Living Building Challenge and meeting it with photovoltaic cells. Then John Brashears comes in and tells this incredibly compelling story about their new offices in Portland, ZGF's offices, and an experiment that they were doing which had to do with on-site wind generation. And they put up 5 wind generators on the roof and did an amazing amount of analysis before they did that to find out exactly where they needed to be placed, exactly what wind generators they needed to use, and how they would even anchor them and move them to that spot. Great story, great experiment. It certainly doesn't generate the amount of energy that this building needs, but it was an experiment for ZGF, and one well worth telling. Here they are. You can see the generators on the roof. Workshop 9, the handoff. This really is the most overlooked, most critical component of building a building that is going to actually operate energy efficiency. And it has to do with our expectations for operations and human behavior and providing feedback to occupants. We had McKinstry bring 2 of their top people in to talk about building operations. They sort of start with this notion that buildings don't always perform as expected. And I know that we've worked with 3 or 4 architecture firms in Seattle to begin to benchmark the buildings that they've built over the last 10 years to find out how they perform. It's just not something our profession as architects and engineers have done. And I think there's been a lot of disappointment that we thought our buildings were doing better, and it turned out they weren't doing as well. These happen to be EUIs, I believe, for, this was a project done by the New Buildings Institute, where they were looking at LEED-rated buildings and their actual performance versus their design performance. This basically reiterates what I just said. It says, most people don't know how their buildings are performing. Most architects don't know how they're performing. And so one of the first things that we do for a homework session is to send people home to find out how one of their buildings did last year and to calculate the EUI. And if they don't want to do that, do it for their home. Find out what their home's EUI is. And then we plot all these on the walls, and it's a good, fun story to tell. McKinstry will spend basically an hour and a half talking about setting up communications with the owner and the operator at the earliest stages of design, the commissioning agent, so that we can start to develop a system of feedback to the operators and occupants of the building through a series of dashboards. And then the protocols that have to be established early on in terms of communication and the sort of level or grain of the metering that would go on and the cost of that metering to provide that feedback. It's a really interesting set of stories. McKinstry is doing a lot of this work in terms of monitoring buildings, contracting for the operations of buildings. all over the United States. Then the last session, which is really the 2030 commitment and what it means to an architecture firm. And Norm Strong and Ron Rochon, Norm Strong, both partners at Miller Hall, Firm of the Year, AIA Firm of the Year, I believe 2 years ago, come in and talk about projects at Miller Hall. And what we reiterate in this session is that if you don't look back, or if you don't set goals and test for those goals during design and after the building has been built, then you're not going to learn the lessons you need in terms of performance. So a building that did this, Terry Avenue, remember we saw these numbers when we first started, 107 for the CBEX number, 62 for the code baseline, 40 for as designed. In its first year of operations, it was operating at 43. And that's a darn good number. You know, it's within 10% of what it was simulated. It has varied a little bit over the last 2 or 3 years. I think it's operating at about 47 now, and there's a small medical office on the first floor. But just keeping in touch with that and knowing that it needs to be continuously commissioned, watching the systems, improving the systems, being accountable to those numbers. So Norm and Ron presented their office. And it turns out that they've been tracking the energy performance of the buildings for about the last 5 to 7 years. And this is a graph of the buildings that they worked on and that either are in construction or have been built and are operating, again, over those last 5 years, I believe. And they're sort of in groups. These are libraries, community centers, these are office buildings, these are fire stations, these are schools, and these are university buildings. The blue line indicates measured data, building actual performance. The red line indicates predicted data or as designed data. So if there's a pair of lines like there are here for the Kitsap County Office Building, administration building, you can see it has a design value EUI of around 45, and it's actually working at around 65. This building was designed about 7 years ago, was built about 4 years ago, and really predated a lot of this interest. These buildings were designed, Pierce County Environmental Services Building was a COAT National Award winner, I believe, in 2003. So they thought, let's go back and look at the energy performance of those. I bet they're doing great. And they found that they were not doing so great. And so that was the motivation to get better. The black line here is what they consider to be the median building in CBEX, and the red line would be the 50% target for them, which was prior to 2010. And you can see that in these office buildings, as they have worked, and here's the Bullitt Foundation building at 0, they've just gotten better and better. And they're doing this with all these different buildings. It's pretty exciting. It's a performance-based practice. And if you look at just the office buildings that we saw in that far left-hand graph, these buildings were done in a time when they really didn't have their eye on energy. You can see that their energy use is quite high. Kitsap Administration Building, again, that differential that we talked about. And then the Lot Administration Building, this just won a AIA COAT award, Top 10 Building COAT award. And its energy data is coming in as we speak. It just opened this last summer. So everybody's excited to hear that. Here, the green line is the 60% savings, and Bullitt at 0. It's good work that you can do. It's a labor of love. It's hard work to get that data, but it's a good, hard work. The other component of being in the 2030 commitment is sustainable operations of the office. So you have to report 2 things. One is, how are your buildings performing in aggregate? So they're not identifying individual buildings. And then, how's your office performing? And Ron talked about this. They developed this plot in 2009 of the company's emissions. And you can look at transportation, materials, waste products. As Ron said last year with this, is that when you're having a really good year, it's really hard in your office to have a low greenhouse gas footprint because there's so much transportation going on, flying. And when it's a not so good year in 2010, it's much easier to hit the greenhouse gas emissions that you target. So AIA gives you sort of an outline to be able to do this in a fairly simple way. There's a round table of architecture firms in Seattle really doing this together, getting together once a month and talking about how they're putting together this information. And it's an exciting group of young practitioners. So that's generally the overview of the workshop series. 10 sessions, 10 different topics, very integrated. From people who are actually doing the work, which is exciting, and slowly but surely building a stronger and stronger community of people focused on high-performance design. Again, the structure of this is generally the review, starting it out, an hour-and-a-half lecture by 1 or 2 people, then an exercise, a real-life case study, and then some lunch. Again, to emphasize this, this is the location of all the folks that came and spoke in the first series in 2009. And you can see everyone in the Seattle series is either coming from Portland or the Seattle area, Vancouver, with one person coming from San Francisco. So if you intend to do that in Idaho, I think it would be great to do it with Idaho practitioners. This is the general structure of these sessions. The sessions 1 through 10 on the left. The session lead for Series 1 or Series 2 is identified here. You'll see, for instance, in session 5, an architect was the lead. That was Rob Pena, and that person was repeated in session 2, or Series 2. The same thing in terms of daylighting. This was Chris Meek and repeated in Series 2. Where right sizing, this is the engineer from San Francisco, and we found a local engineer, Peter Alsbach, who gave that series in Series 2. Then we keep track of the case studying, people who are offering case studies. So we essentially develop a speakers bureau around this at a regional level. So last comment is you have a form. We really ask you to fill out the Better Bricks evaluation form and to be knowledgeable that somebody may be contacting you in the future from Better Bricks to find out how informative this series was. Thank you. Yes. Could I ask, are there any questions or generally understand? Yeah.
Joel, don't actually see many practitioners in your work. But one thing I've noticed about the examples you showed and the firms who made the presentations is that there's a real leaning toward big buildings, big systems, big budgets, I assume. It's just that stuff is probably not going to be applicable in my practice. I'm wondering, is there a way that you can make it more applicable?
You can, by having the types of buildings that you do typically here. You know, for instance, in Seattle, we commonly see office buildings of 10 stories plus in the sort of urban core of Seattle, Bellevue, Everett, Tacoma, where that isn't a common thing in Boise or in Idaho. So I'd assume that you would build an information base in practice around office buildings that are 3 to 10 stories in height and have lots of examples of that. So that's the power of building it locally rather than bringing people in from Seattle or Portland or New York or Chicago to talk about these things.
Yeah, I was gonna, if I
Sure, Gunnar, step right in here.
Okay, my little.
Turn that mic around so we can use it.
Or just grab it, I guess. Yeah, I guess also, Doug, yeah, we're doing the committee that we put together to try and build up the sessions is we're looking for especially folks that know the high mountain climate, and then are doing building types that we're doing in Idaho. So, we're definitely trying to work on getting people that know the area and know the climate. So that's one of the things that's great about the session, is because you pull in the people that know the most about the stuff that you're doing here. So
yeah, I think there's a really important thing that really was sort of missed, and that is in Portland, in Seattle, in El Paso, in Atlanta, in Washington, D.C., which are all cities that are either doing this or on the verge of doing this, there's a steering group of local people who decide on what's going to get said and how it's going to get put together. So there are resources with Seattle AIA that you can draw on, or through Better Bricks you can draw on. But you really put together your own series based on the kind of architecture that goes on where you are. It's really necessary.
Gunnar, could you tell a little bit about the working group that you've put together?
yeah, it's actually that was my thought. So I was actually going to say, if anybody's really interested in getting more involved with the putting this stuff on and the subcommittee that we have for the state AIA. I've been leading the committee, and if you have interest in, and also if you just have interest in general for the series, and it's happening in August, please email me. It's Gunnar G. That's GUNNARG at uidaho.edu. But essentially, we put together a committee of both AIA and non-AIA folks in the building industry. So we're looking to try and get a good cross section of people to try and make some of the decisions about who we're going to bring in and what they're going to do. Scheduling the events, looking for sponsors. The local utilities are involved as well, and so we've been working on that, and we're looking at starting to kind of roll out the marketing to people who would be joining those sessions here coming up in the next month or so. So hopefully you'll see some information coming out. Again, if you do have any questions, just please email me or contact me. The contact information is on the website there below the screen. Essentially it's really local. It can look extremely different where they're doing it in Atlanta, and I'm sure it's quite a bit different than it is in Seattle.
So, it needs to be really emphasized that this is a lot of information. And I know all the other groups, like we were in Seattle the first time around, there were one or two sessions that we just felt like we didn't have the people there to do. So we looked to Portland, or we looked to San Francisco and brought somebody in. And then people were sitting in the sessions and sort of saying, I could have done a better job than that. And they let us know, and we talked with them and we agreed. And so slowly over time, you're building this core group, where in the beginning you may draw on some people from a little bit further away for 2 or 3 or 4 of the sessions. So that certainly happened with us, and I know it's happening this time in Seattle and in Portland.
Yeah, I guess so. Well, it was more. I guess it's a question too, Joel, and maybe a statement as well. But most of the folks that have been doing it over there have been firm principals and project managers and more upper management folks in the architecture and engineering firms. Isn't that right? Participating, yeah.
Well, Peter Osbach is head of mechanical engineering for Arup Seattle. Tom Marseille is managing partner for WSP Flack & Kurtz. So you'd have to say yes. On the other hand, Chris Chatto, when he started, the first time he gave this talk, he was an architect with ZGF, and now he's a principal. So there's a certain amount of variety there.
And actually, how about I was also asking, what about the participants themselves are also...
Oh, the people taking the class.
Yeah, people taking the class.
I think dominantly they're project managers and principals. They're not partners. So they're the people really doing the work and responsible for design delivery, especially if it's a larger firm. If it's a smaller firm, we see a lot of owners, partners.
What's the time frame upon which all these sessions happen? Is it like a boot camp, like 2 weeks, or is it spread out? What's the distribution look like?
The way it's being done in Seattle, the way it's being done in Portland, and there's a San Francisco offering that isn't a part of the sort of Seattle AIA product. And they're doing it once a month for 4 hours. over 10 months. I know that they're considering doing it in several different ways around the country. And I think you're thinking about doing it in
Very similar.
in 2 or 3 days? Or is
We consider that we're going to do the once a month format. We picked the dates, so we'll release those pretty soon. And we're going to do that once a month on Fridays, very similar to what you did. And so it'll be 4 hours on a Friday once a month, from August until the of 2011 through to the spring of 2012.
And you were really clever about splitting it over the years, I recall.
If the CEUs, of course, are one thing, but I mean, the level of education that you get from the program are the big benefit. But the CEUs, there's 40 CEUs offered for the program, and so you could get 20 for each year, and that was kind of what we wanted to split it up and get.
Is that what you meant, Sherry?
Spread out over the year.
Yes.
Creative marketing.
Value added.
Yeah. Performance-based design.
How many people participated in Seattle last year?
First session, there was about 75. And the second session, there's about 75. And the third offering, which is going on, I think, this week, I think there's, again, about 75. I think everyone's been pretty surprised that it's maintained.
Waiting lists.
Yeah,
as well.
yeah. It's been good. Yeah.
Seattle's 4 million.
How much is it? If you're a member or non-member student.
I haven't been involved in the business side of this at all.
I think for associates it's at
So around $400 for an associate.
and for regular AA members.
And that's in Seattle. Is that right,
That's
Joel?
what's on the screen.
'Cause we haven't finished setting our prices yet, so that's forthcoming very soon, though. But it'll be equivalent to what they're doing in Seattle.
Mm-hmm. And the first couple of offerings of it in Seattle, Better Bricks was definitely a sponsor and really helping that get off the ground. And I suspect the same thing will happen with you. Yeah. Now they're pretty much on their own.
And Idaho Power is also sponsoring the program as well, so we're looking for some more sponsors out there too. So if you're interested in doing that as well and getting some promotional stuff. But any other questions?
It's really great to see some familiar faces.
Joel, I didn't understand on your one chart where you said S1, S2, those were just different versions of the same thing.
There were Series 1, Series 2. There's Workshop Series 1, Workshop Series 2. Series 1 happened dominantly in 2009. Workshop Series 2 happened dominantly in 2010. Now there's Workshop Series 3 going on. And Tom Marseille is the moderator.
We have a moderator selected for our sessions as well in Idaho, which will be Ken Baker. And we've got about half of the speakers, I think, almost pinned down.
Can we see who those are?
Yeah, we'll be now that we've got the dates pinned down, we're gonna start putting together who the speakers are and send out an informational packet to architects and engineers in the state.
You're gonna have little trailers on the web, for come and see, Doug Cooper and.
Are people going to be able? Do you have to be present, or will you be able to participate via video or something?
We had looked at the cost of doing broadcasting. It's a pretty steep cost to broadcast it out to the various regions, and also to keep the quality of the education up, because like Joel said, there's a lot of interactive stuff that people are doing. It'd be pretty difficult to moderate each of the sites that we might do to have a lot of that interaction and some of the quality. It's a 4-hour session. It's tough to sit in front of a computer screen for 4 hours.
Where are you going to
too,
offer
so.
it? Where's it going to be?
We're going to do it in Boise, and we're looking at a sponsor that's willing to give their space for free. So
That's what happened in Seattle. The City of Seattle and the DPD, Department of Planning and Development, sponsored the event and then gave them a meeting place at City Hall. So that was great.
thank you very much, Joel, for coming down here. It's good to see you.
Good to see you.
Thanks all for coming, and thanks to Better Bricks and Idaho Power for sponsoring the program. And we'll look forward to seeing you all at the program when it starts in August. Thank you, and we'll see you later.